Hello students, continuing with my lecture series on AKTU Energy Science and Engineering Unit for Conventional and Non-Conventional Sources of Energy. In lecture 1, I told you about approximately all the various sources of energy available on Earth, the renewable, non-renewable, wind, solar, wave, tidal, and now I am continuing my discussion on fluid energy, and I am briefing you certain formulas related to fluid energy and how they create pressure difference. Okay, let me continue now. I explained you in my previous lecture about the properties of fluid, that thermodynamic properties of fluids are that they have density, temperature, internal energy, pressure, specific volume, and specific weight. Fluids do not have a fixed shape, and they very easily get deformed, or they take the shape of vessel or container in which they are put. The mechanical properties of fluid are viscosity and surface tension. Viscosity is a measure of fluid's resistance to flow. It was asked in section A, define viscosity. And you can expect a numerical on this formula of viscosity, which I'm just going to do with you. So fluids resist the relative motion of immersed objects through them, as well as to the motion of layers with differing velocities within them. So viscosity is given by what is force upon area, pressure or shearing stress, and velocity gradient. That means a rate of change of velocity with distance. Gradient in physics means slope. So viscosity is mathematically given by shearing stress to velocity gradient, and stress is force upon area, gradient is del V by del Z. So force upon area is equal to viscosity into del V by del Z. Force is also known as mass into acceleration from Newton's law. So I put acceleration is rate of change of velocity here. A I have put as del V by del T. So I get force upon area is equal to coefficient of viscosity into del V by del Z. This is important. You can be asked to define viscosity, or you can be given a very simple numerical on this also in section A, not numerical but definition, section B, a numerical. So the standard unit of viscosity is Pascal second, and 1 Pascal, the most common unit of viscosity is dyne second per square centimeter, and this is known as poise. This can be asked in section A, define poise. And 10 poise is equal to 1 Pascal. Here I have given few relationships. Now, continuity equation. It is defined as the product of cross-sectional area of pipe and the velocity of fluid at given point along the pipe is constant. How do we get this continuity equation? A into V equal to constant. See, look at this diagram here. Whatever amount of water has entered here, only that much amount will exit out here. Yes, the shape can vary, the velocity can vary, that is all. So that means as per the principle of continuity equation, water is flowing continuously. The product of area into velocity is a constant. Section A question, it can be asked. And section A question again, what is the principle of conservation of energy in fluid dynamics. So Bernoulli's principle states that the total mechanical energy of the moving fluid is a constant, and it represents the principle of conservation of energy in fluid dynamics given by pressure plus half rho v square plus rho gh is equal to a constant. P is pressure, half rho v square I can correlate to kinetic energy, and rho gh I can relate to gravitational potential energy. So V, the velocity with which the liquid has entered my tube, or it has entered my pipe, or wherever I am doing my experiment. Rho is my density of fluid, H is my height of container or my experimental apparatus, G is acceleration due to gravity. Now, this is a constant. Pressure plus half rho v square plus rho gh. So this is also known as Bernoulli's equation, also known as statement of conservation of energy for flowing fluids. And also P here represents pressure energy, half rho v square represents kinetic energy per unit volume, because kinetic energy is half mv square. Mass is volume into density. I am writing kinetic energy per unit volume. Rho gh, potential energy per unit volume. This is very important. Section A question, very important. What are the different terms? Which expression represents principle of conservation of energy in fluid dynamics? What is Bernoulli's principle? Write the mathematical expression of Bernoulli's principle. Very, very important. Types of fluid flows: steady, unsteady, laminar, turbulence. Turbulence means, like you say, the whole streamline flow loses its streamline motion and the particles are not following their path in a sequence. Uniform is till the time it is running in a uniform way. Then non-uniform, compressible, incompressible, rotational, irrotational, 1, 2, and 3 dimensional. One line definition for each. In fact, if this question comes, you make this table like this flow diagram, and here only you can write one line explanation for the same. This will fetch you very good amount of marks. Steady and unsteady flows, in which the fluid characteristics like velocity, pressure, density, etc. at a point do not change with time. Unsteady flow, in which the fluid velocity, pressure, density at a point changes with time. Uniform and non-uniform flow, in which the velocity at a given time does not change with respect to space. Non-uniform, velocity at any time changes. Laminar, in which the fluid particles move along well-defined paths of streamline. Turbulent, irregular, zigzag. Compressible, density of fluid is changing, you can compress it. Incompressible, density is not changing. Rotational, fluid particles while flowing along the streamline also rotate about their own axis. Irrotational, they do not rotate. One dimensional, such as velocity, water flowing through a single directional pipe. Two dimensional, where you have just spread the water, in which the velocity becomes a function of time and two rectangular space coordinates. And when it is taking three mutually perpendicular directions, then it is three-dimensional flow. This is a big demarcation. You can accordingly see how many marks the question is and then write your answer. Lifting force. Now, have you seen lifting force acts on a body in the fluid, and it can be simply given by the formula F is equal to half rho V square A into lifting coefficient. This force is same as which I derived with you in the previous lecture here, and you don't need to go into higher details of this formula, but yes, here wind energy formula here, lifting force, and whichever coefficient they ask, just multiply it with that coefficient to get the answer. So lifting force here becomes CL into half rho V square A, where CL is lifting coefficient. Drag force, it can be CD half rho V square into A, where your CD is the drag coefficient. Lift. A fluid flowing around the surface of an object applies a force against it. It makes no difference whether the fluid is flowing past a stationary body or the body is moving through a stationary volume of fluid. Lift is the component of this force that is perpendicular to the oncoming flow direction. So lift is always accompanied by a drag force. Here, look at this diagram. See, you are lifting, so this will be accompanied by a drag force. You can take the example that common meaning of the word lift means to lift opposite the weight, or lift can be in any direction with respect to gravity. Simple English meaning uthana, lift. And when an aircraft is cruising in a straight and level flight, most of the lift is opposing the gravitational effect. And when an aircraft is climbing, descending, or banking in a turn, the lift is tilted with respect to the vertical. Look here in this diagram, you are seeing it. It is tilted with respect to the vertical. Lift may also act as a downforce in some aerobatic maneuvers or on the wing of a racing car. Lift may also be largely horizontal, for example, in a sailing ship. So lift is defined as the component of the aerodynamic force that is perpendicular to the flow of direction, and drag is the component that is parallel to the flow of direction. This I have discussed with you. This question was actually asked in the AKTU exam. So once again, conventional, non-conventional, the non-renewable ones are the conventional sources of energy. The renewable ones are the non-conventional sources. Conventional go more for commercial and industrial applications. Non-commercial are the household applications. Conventional, example, fossil fuel. Non-conventional, solar energy. Now, wind energy are mainly three types: utility scale wind, disturbed or small wind, and the offshore wind. This wind power of wind energy, we will discuss again with wind turbines. This question has been asked in AKTU 2021 paper. How are wind turbines defined? Explain neatly. First, understand what do wind turbines do, on what principle they are based, and then I will explain you the diagram. Wind, hawa. Wind turbines work on the simple principle that instead of using electricity to make wind, like a fan, what is a fan doing? Mechanical energy is getting converted. First, we are switching on the fan. That means we are giving it electric energy. Electric energy is being converted to mechanical energy to run that fan. But here we will do the opposite. Wind turbines will use wind to make electricity. Wind will turn the propeller like blades of a turbine around the rotor, which spins a generator, and it will create electricity. Wind is wherever we have to set up the plant, we have to see many things. Firstly, that wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blades, which works like an airplane wing or helicopter rotor blade. The force of the lift is stronger than the drag, and this causes the rotor to spin. Look at this diagram here. Windmills are usually, they first require one big long tower on which they can be placed, because this place there will be no obstruction to the wind. If the tower height is less, then buildings, etc., can become an obstruction to the blades to get sufficient amount of wind to rotate, and they are fitted with low speed shaft, high speed shaft, a generator, and rotor and blades. So when wind starts flowing, the blades like fans start moving, create energy, and this energy is converted into electricity. The energy needs will be determined by the size of the turbine. Wind turbine economize the nets are maximized with the project size according to which they are designed. Regardless of the project size, projects connected to the electrical grid will require utility approvals and may require grid impact studies before the construction can begin. Now, types of wind turbines are basically the two types, horizontal and vertical. Horizontal axis turbines are what many people picture when they are thinking of wind turbines. Most commonly, they are having three blades, like you can say your simple fan, and these blades are mounted on these long high-ended poles so that wind comes and these blades start rotating and they create energy. This vertical wind turbines, if you can look at it, the diagram looks more like the egg beater style. It is not having only three blades. The diagram is the positioning of the vertical axis wind turbines. The setup is a bit different from the traditional ones, and the residential scale on-site energy use is less than 10 kilowatt. Self-commercial scales also go in for 10 to 50 kilowatt. It depends on what type of blades you require and the turbine setup as per your application. Like the residential wind turbines may work as supplementary power supply. Large turbines will require big towers between 80 and 140 feet tall, above ground level. Small wind electric systems can be used for small residential societies for functioning. Power industrial corporations again are going to require big wind turbines. The offshore wind turbines are able to capture large amount of ocean winds and generate vast amount of energy. The disturbed winds, when they are working, even they manage to generate electricity. Wind farms, look at this picture. Can you see large number of wind turbines in one place? This is known as a wind farm. So large number of wind turbines built close together is referred to as a wind farm, and this sends electricity to the grid. Or you can say a wind farm is a group of wind turbines in the same location used for production of electricity. Geothermal, geo, geography, thermal, thermodynamics or thermal physics. That means that heat from the internal energy of the Earth's surface can also be used to generate electricity. And they work on the principle like coal on nuclear power plant, and it is geothermal energy which is being utilized here to run my turbine and convert it into electricity. Like you must have heard Earth having hotspot areas where molten rocks are formed in the Earth's crust and they are pushed up because of geological changes. So when underground water comes in contact with this hotspot, steam is produced. This steam, like steam engine, it runs full one engine. It has lot of power. So the steam is routed through a pipe to a turbine and it generates electricity. Look here, underground production well for steam water extraction. This steam has been used to run this turbine, and then an alternator is attached to it to give you electricity in far off places. And for a cooling system has been set up along with it, so that in case excess heat at times get flows, the cooling system can cool it down. This type of block diagram is the general diagram for the three types of geothermal power plants. One uses the dry steam to run this turbine. Turbine generates electricity, and one is the flash cycle steam plant. These types are most common. Flash means they are occurring in naturally occurring high quality steam, has been used to run this turbine and generate electricity. Binary cycle plants make use of lower temperature water than the other two types of plants. This question has been asked and it is important. Differentiate between geothermal power plant and thermal power plant. See, this is a thermal power plant. Here, the thermal or the heat has been used to boil, create steam. Steam runs this turbine. Compare it with the steam engine, generates electricity and a cooler here. Now, the difference between the two is that geothermal is utilizing the energy of the earth, the natural one. But my thermal power plant is utilizing the burning of fossil fuels. So hotspot areas where molten rocks are formed in the earth's crust or the underground water with hot spot steam is used in geothermal to generate electricity. In thermal power, fossil fuels are burnt. These are less flexible. Thermal power plants are more flexible. Geothermal cost is high because lot of digging beneath the earth goes on to get the energy generation of the earth. But thermal power plant, the cost is low. The geothermal are used for power generation. Thermal ones are used for industrial processes. Let me discuss one very simple numerical. Basically, this numerical is very simple, but it requires a bit of conversion factor, so that I will clear you in this numerical. Do it along with me. A 1000 megawatt, that means if I convert this into watt, how much do I need to do? 1000 megawatt. So geothermal power plant is operated for 11 months in a year. Now, what is the problem with this numerical? I will either have to convert this 11 months into hours. This is what I have done. See, months, 12 months, 11 months, 24 hours in 1 day, and 1 month 30 days. So 24 into 30 into 11, 7920 hours. 1 month is for maintenance shutdown. The cost of electricity supplied is ₹3 per kilowatt hour. Calculate the total earnings. Total energy generated megawatt into hour. How much have I been given? 1000 megawatt into how many hours? 7920 hours. Total cost of energy, we take usually cost of energy in kilowatt hours into rupees per kilowatt hour. So for kilo, I will have to multiply this 7920 into 10 to the power of 3 by how much? Rupees 3 per kilowatt hour into 3 to get my answer. Ocean thermal energy, or simply OTEC. It has been asked, 10-mark question has been asked on OTC twice. It is the process of using ocean itself as a solar collector. This technology is also still under lot of research and utilizes the slight temperature gradient between the warm surface of the ocean and the cooler water deeper down. Why does this temperature difference occur in oceans? Oceans are all exposed to sunlight. So what happens is that the sun increases the upper layer of water, temperature of the upper layer of water, while the lower layer is still cool. So this del T, according to thermodynamics, I can also use it to generate electricity. So here my water has got heated. This heat energy I have used in running my turbine. Turbine has helped me in creating electricity, and for cooling I have used a condenser, cold seawater, and even an ammonia pump. Because what happens is at times large amount of energy gets generated, and I need to keep a cooling system always when I am setting up an energy plant. So OTEC, or Ocean Thermal Energy Plant, it operates like any other thermal plant. They require the use of Rankine cycle. It has been discussed in Unit 1. Warm surface seawater heats up some fluid with a low boiling point, and this temperature difference gives rise to generation of electricity. Environmental impact of OTEC is that it is nature dependent. That means, like the day it is cold or thunderstorm is there and upper portion of the ocean has not heated up, then it is not going to work. It depends upon weather and climatic changes. Okay, tidal powers are harnessing the energy from the tidal force and wave action in order to generate electricity. Unlike other energy flows, it is predictable source of energy because tides occur at expected time of the year. And this predictability has an advantage over wind and solar power, because wind and solar power are nature dependent. Any calamity and they both fail. Okay, so the tidal ones dominate here. The three basic ones are dynamic tidal power, which is a technology that uses the difference between potential energy and kinetic energy. Tidal steam generator makes use of moving water to power turbines. Tidal barrage works similarly to hydroelectric dams. Benefits are, it is not much having environmental impact, but yes, drawback is that they are very costly. Wave power. I will continue this in the next lecture. Thank you. Please subscribe to my channel.